Hi, here is yet another practice problem using integration by parts with the indefinite integral, part 5. First, I understand that there's tons of tutorials out there for the same thing. Therefore, if I can't be a help, I'd highly recommend you checking out Professor Leonard, who is an extraordinary supplement to my science classes, Professor Dave Explains, organic chemistry tutor, Patrick JMT, and such. I will probably have descriptions or links in the description below. I'm fully aware that I may not be able to reach through to every single person watching this. I'm definitely not proclaiming a breakthrough that I discovered the best way to teach this, nor am I the best tutor in the world. I just simply want to help out the best I can, and teaching is my passion. So let's get started. We have the integral of e to the x sine of the quantity 5 minus x dx. That's very important right there, the differential. So this is integration by parts. You notice that it's a product, and we should know that the formula, which I derived in a previous video, is u dv equals uv minus the integral of v du. Okay, so this integral of u dv is right here. Okay, so what's u and what's dv? Well, we have to choose, and sometimes it doesn't matter what you choose, and other times it does matter what you choose. In this case, I'm just going to let u equal the exponential right here, and therefore dv is what's left over, which is sine of the quantity 5 minus x dx. Now du will equal the derivative of u, e to the x dx, and then v will equal the integral of sine of the quantity 5 minus x. And the integral of that is cosine of 5 minus x. And just in case you don't see that right away, let's just prove it to ourselves. The derivative of cosine of 5 minus x is going to equal, well, the derivative of cosine is negative sine. You keep the inside function before using chain rule. So the derivative of 5 minus x, well, the derivative of a constant is 0. The derivative of negative x is negative 1. So that's times negative 1. And that's going to equal positive sine of 5 minus x, which is precisely what we have here. So if you integrate something, then take the derivative, and you get that same something back, then it testifies that you did it right. So now I'm ready to solve. I highly recommend that you set it up like this, because you could easily draw arrows either on the paper or in your head. Draw arrow from u to v, because we're going to multiply these two, and then we're going to subtract it from the integral of v du, which is essentially multiplying these two. Normally you don't have to rewrite this, but I'm going to rewrite it anyway, and you'll figure out why later on towards the end of the problem. So I'm just going to rewrite the original problem. So, and it's like right here, the integral of u dv, well, that's what that is right here, u dv, and that's going to equal u times v. We chose what u was, we chose what dv was, did a little calculus to come up with du and v, which is needed for this. That's going to equal, so this is going to equal u times v, which is e to the x cosine of the quantity 5 minus x, and you subtract it from the integral of v times du, which I'm just going to put the exponential right there, with the differential right there, dx. Okay, here we can't integrate that without integration by parts again. So we let u equal, now if you choose the trig function to be u, assuming that would work, then you would have to use the trig function here, so in this case cosine. But since we chose u to be the exponential here, we would have to likewise let u equal e to the x. So if this is u, well, dv is going to be what's left over, which is cosine 5 minus x dx. Okay, so du is going to be the derivative of u, and v is going to be the integral of u, which you should get negative sine 5 minus x, and of course you could check it right here. I invite you to do that if you want, but that is what the integral is. And then you could do the same thing. It's u times v minus the integral of v du. That's what that is. So I'm going to rewrite this, and by doing so it would probably avoid errors or mistakes. Okay, so this whole thing equals u times v minus the integral of v du, but it's subtraction right here, so it's best to put parentheses or brackets. So this thing right here equals uv, which is negative e to the x, sine 5 minus x, minus the integral of v du, which is e to the x sine 5 minus x dx. Now I know that's a negative sign, but I'm going to take out that negative 1, and that would change that into a positive. Okay, and now once more, I'm going to distribute in that negative right here, change that into a positive, and a minus. Okay, now we have the same thing over again, and you would think, well, this is just going to repeat itself like a cycle over and over again. Well, it is solvable. You just have to notice that this is like an algebra equation, and you see that we have a term here, this integral here, and we have the same integral right here. So let's try adding that integral to both sides. Okay, so when we do that, notice that this cancels out, and you are left with 2 times the integral e to the x sine 5 minus x dx. Okay, and that's going to equal, now I'm going to factor out that e to the x right there. That canceled. And then I'm just going to divide everything by 2, pretty much. Going to divide that by 2. And what you're left with is that the integral e to the x sine the quantity 5 minus x dx equals e to the x over 2 times the quantity 5 times the quantity 5 minus x plus sine times the quantity 5 minus x plus c. And notice that we are solving for what is the integral e to the x sine 5 minus x dx. Well, we have that same thing right here set equal to something. So with this, we actually found the answer, which is this right here. And that's the answer. And yes, it does take practice, a lot of practice. And I could totally testify to why practice is good, personally, and just never giving up on my passion. So likewise, I'm encouraging you to never give up on your passion, whatever your major is, why you're taking this class, whether it's engineering or medical or whatever it is that's on your heart. I encourage you to stick with it if it's truly in your heart. Just don't give up on your passions, and have a nice day.